Okay, so number 9.627b, we would like to show that if you take a complex number z, right? So think to yourself there, a plus bi, or r e to the I theta, right? One or the other.
Okay.
If you take a z, and you do to that z multiply by I, right?
Okay. So AI plus BI squared. That's enough.
Yeah, so if you thought about I times z, you could think about that as ai plus bi squared, which would be ai minus b, right?
Yeah.
Doesn't seem super helpful. Because they want me to show that if you do this, that thing is really just rotate by 90 degrees counterclockwise. Like they want me to show that those are the same thing. That if you multiply by I, you may as well just rotate the complex plane by 90 degrees. Okay, so if it's not obvious from the A's, where might it be obvious from?
Well, RE to that theta.
Might be obvious in the other one, right? So I'm going to look at IZ, right? So take IZ and think about that as I times R e to the I theta, right? And now this is really trippy because I want you to replace I with R e to the I theta and figure out what the theta is.
So you have RE to the I theta to the I.
So like if you look at I, where's I sit on the complex plane? So I want to do 0 plus I, like plot me that point. Yeah, go over none, go up 1 unit, there you are, I. This is 1 unit long.
Okay.
What's the angle there?
90
Wait.
90 degrees.
If the 1 unit long, what does that tell you about?
It's by eyes.
Yeah, it counts by eyes,
Degrees
right?
of I,
I think that tells you about the radius.
Yes.
You see that?
Okay, so the radius is 1.
So my claim is that
I's radius.
I's radius is 1,
Yes.
and then what's the angle?
90 degrees.
So e to the I pi over 2.
Yeah.
That feels really screwy, right?
So
Like
just-
what I just told you is that I is e to the I pi over 2.
That makes sense.
That feels really weird, right?
It's overcomplicated.
Yeah, it seems like, dude, you went from something pretty simple to something really jacked up, right? But in the process, right, I went from Cartesian coordinates to polar. Right, in Cartesian coordinates, I'm at the point 0, 1, right? That's what
Yeah.
this guy is.
That makes sense when you know that when we did, because we did that e I
So-
to the pi is -1.
Yeah.
So that makes sense that e to the I, if you did like square root of that, then.
Uh-huh. Yeah, so you can see this from the other problems we were just doing, right? E to the I pi is like this part. That's -1. And then that thing's square rooting that. So of course this should be I. You see that? But this whole guy here, right, is like an R of 1, comma, pi over 2. Right, so that's a polar point. You guys with me on that? So let me shove that in here for I. So that's a e to the I pi over 2 times whatever my z was, right? Radius e I theta. Okay, now which part is the e I pi over 2 going to affect? Is that going to affect the radius?
Yeah.
No, it's going to affect the I theta.
Yeah, it's really just, it goes with the I theta, right?
Oh, yeah.
Like those seem really
Yeah.
similar.
Yeah.
What should you do with them?
Combine like
Combine them.
Yeah, you kind of want to combine like terms, right?
Power, combine powers.
But they're
the same.
like bases with kind of funny powers, right? So what's the rule for those?
Add them.
Add the powers. All right. So you get r e to the I, right? There's an I in both pieces, so I'll just factor that out.
Pi over 2 plus theta.
And then you get a theta plus pi over 2.
That makes sense.
Oh, snap! That's leave the radius alone, rotate by 90 degrees.
Counterclockwise.
And adding 90 is a counterclockwise rotation.
That's cool.
Interesting.
This makes sense.
That's a pretty large subtlety.
This makes it not a subtlety.
I don't know what to circle up here.
Sorry.
Stop rattling.
Sorry.
I have no idea what to circle up here, right? Because what's the answer here?
Yes.
Yes,
Yes,
it's
you're
possible.
correct.
Yeah, I think the answer is the whole explanation, right? So if you wanted to do a nice job explaining this, right? You'd give this part of the calculation, right? All of this stuff. And at each stage you'd say something like, okay, so in here I convert to polar, right? Convert z to polar. And then in this next step, I converted I to polar. Okay? And then in this next step, I use an exponent rule.
We should just put that in the sentence.
Yeah. And then at the end, you would say, and I noticed that this is rotation by 90 degrees counterclockwise.
Possible.
So, when you multiply by I, you really may as well just rotate by 90 degrees.
Ooh.
Cool?
Yep.